Hi everyone, I am Mustafa from OpsGenie. I'm a site reliability engineer at OpsGenie. And since it's a lightning talk, I will be going fast. So if you have any questions, please ask me forward after the event. So there's a philosophical question. If a tree falls in the forest and no one's around to hear it, does it really make a sound? So if an alert occurs in a system and no one takes an actual action, is it really an incident? So you have containers. All of you probably have some containers and they crash every day. And you connected Prometheus and Alertmanager to forward the alerts. But if you don't forward them anywhere, they are lost. You can use emails, but what if the person does not get email? Email is not very reliable, and there is no proper acknowledgements. So you can use Slack integration of the Alertmanager, but the same problems still exist. For instance, what if the person does not see the Slack notifications? What if he is sleeping or there's no one else? So you should be handling your incidents the right way. So you should be using systems like OpsGenie to properly handle the incidents because you might have different requirements. So as you are writing alerts, you are probably writing the alerts to plan before the possible incidents. So you should ensure they are not missed and the right people are notified on time. So, and you could also provide insight to your operational efficiency. If an alert occurs and you respond it in 1 hour, it's not very good for your operations. So regular alert manager has these features: grouping, inhibition, and silences. With using OpsGenie, you could also handle routing, on-call scheduling, and you could also use multiple notifications so no one can sleep properly at night. And with other integrations, you can take the alerts to other systems as well, and you could also do some collaborations. So the integration is pretty straightforward. You create a Prometheus integration and it gives you an API key. And when you integrate it with the alert manager, it's immediately on OpsGenie and on your phones and whatever you like. Imagine this sample use case. In midnight to 36, your importance service is dead. And Prometheus and alert manager is notified. But unless you are using Slack all the time and hearing all the notifications, you won't be able to see it. So when the alert is forwarded to OpsGenie, it has the proper tags of teams and finds out that the John Doe is on call. And as it is late, it directly calls him without sending a push notification, so he can wake up and check the alert. With the alert, he goes to OpsGenie web UI and sees the playbook and sees that he should do a custom action. With he gets additional logs, but he cannot solve it. So he notifies secondary responders, and they add some notes of the alert via the Slack integration. So another responder can, based on the note, notify that the previous deployment has gone wrong and notify that the John to redeploy the latest stable version. So John rolls back the deployment and the metric is back to normal. So Prometheus closes the alert. And when it's the morning, the team lead solves that you responded time in 5 minutes, and he is happy. Why it's important to have this kind of pipeline? Because if you are writing alerts, you should be you are writing because that you want to have an always-on system. It's important that you also take actions very quickly, and using a tool like OpsGenie can help you with the taking proper actions on time and not missing any actions. If it is very long for you, alert manager is better with OpsGenie, and each action should be taken for an alert as soon as possible, and right person should be notified. Just writing alerts without planning is not enough, and the process of your alert pipeline should be efficient, and it should be easily monitored on what has been done on alert. So if 5 persons are acting simultaneously, you don't want to ensure a chaos to to increase your downtime. And OpsGenie is a nice tool that can help you for this purpose.
Hello, I'm Max. I want to do not one topic, but two topics because I got the entire 5 minutes. So, no. I only want to do one topic. Yes. Okay, cool. All right. I'm Max. You might know me from a couple of projects, probably Prometheus Operator or Alertmanager related. Yes, okay. Quickly, we recently switched the clustering library of Alertmanager from 14.0.14 to 0.15. And as you might have noticed, we hit a couple of issues with that. All resolved, of course. And to not hit any of those ever again, I looked a little bit in how we can improve our testing on Alertmanager. And I want to introduce property and model-based testing approach, which I've been working on, which is not fully done yet. All right. So we already had this acceptance test framework for Alertmanager, which only worked for a single instance. And I extended this a little bit to also work against clusters. And taking this one step further, the idea is that we first of all do model-based testing. So instead of like simply running our tests, we run our tests both against the model and the system on the test. So for example, for a database for etcd, this would be simply running etcd on the one hand and a key value map on the other hand, and simply comparing the outputs of the two. And if that works, then either your model is wrong or your database actually works. So this is the same approach for Alertmanager. So on the one hand, we have the model, which is a single Alertmanager instance, as this is perfect. And then we have the cluster of Alertmanagers as the system on the test. Then in addition, we can go one step further. We can do property-based testing. So a property of Alertmanager has a lot of properties, which we would like to break. And to do that, we find the random inputs and see whatever breaks, and then hopefully reduce those inputs to a smaller set, which we can easily comprehend, and then go from there. You might have heard of this from Haskell, from QuickCheck. I think something similar exists in the Scala world, probably in every language. Okay, cool. How does this work for us? First of all, we generate a random pool of alerts. I'll go a little bit into detail on that. Then we have our system on the test, so the Alertmanager cluster, and then we have our model, single Alertmanager instance. We run the alerts against both of them, collect the notifications at the end, and hope for them to be the same. What can we randomize here? First of all, we can randomize the amount of alerts. We can randomize the timing when we want to send alerts. We can randomize the labels, the configuration of the clusters, the cluster size, and so on. So where's my current status? I'm randomizing the amount of alerts, and I'm randomizing the time that I run against the system. And yeah, I only have 5 minutes, so I'm not going to show this live. But this is how my cluster looks right now. The CNCF was so nice and gave me a really beefy machine. Really very bad that it's not used all the way. Anyways, it's running right now like, I don't know, 200 constantly, 200 Alertmanager instances. Those are either a cluster of 3 instances or a single instance, and running randomized inputs against those. Yeah, let's see and hope to find some issues, or hope to not find any issues. Yeah. All right, second topic. Others might have seen the OpenAPI rewrite of the Alertmanager API v2. Why would we do this? Alertmanager has an API already, the v1. A lot of people have been complaining about no documentation, and you simply have to read the Go code, and this not being very consistent. So I looked a little bit into this. How can we fix this? Well, the new API is fully specified via OpenAPI, which is the old Swagger, I guess. I think Google can give better answers on how the two relate. Anyways, it's fully specified in that. So we generate most of the server code. We only have to write the handlers, which is already all done. And in addition, in the long run, I also want to auto-generate the client, which is right now Elm as the front end, both statically typed, so we can have a nice contract between the two. And what this means for all of you, well, first of all, contributing must be nicer to the API in general. And in addition, we have free docs, or free docs, pretty good docs. And you can generate all your clients, whatever language you have. So if you want to integrate with Alertmanager and you want to generate a Bash client, there is an open API generator for that. Thank you very much.
Hello, everyone. Can start. My name is Andrey Markelov. I'm from Infobip. Also, I'm one of the leaders Russian Atlassian user group. Today, I'm going to talk about monitoring Atlassian applications. So, Atlassian is currently the fastest growing company in the worldwide, and this is 4 main products which is used anywhere. In the different areas, banking, oil companies, etc. If we have downtime on Atlassian, despite on this is internal tool, I saw that it lost thousands of dollars. Atlassian has some JMix metrics, but it's not enough to determine the root cost of the problem. And recently, I developed plugins for these all products, Prometheus exporter, and it helps to solve these problems. This is some advantages. Also, it's not required to restart application to just install plugin. It's got it. So let's see some example. GR exporter, it provides many different metrics, GVM metrics, behavioral, license, etc. Let's see some example. For example, we can monitor authorized session. For example, company bought the licenses for 2,000 users, but we can see on the monthly perspective only 300 users use it. So the next year, company can save the money to just bought a less amount of resources. Request duration. Actually, now we can exact now on which time slowdown system can happen, and we correlate it with some internal process to determine what the root cause. There is some pre-built dashboard already on Grafana. Can download and use it. So also Confluence exporter, we can get all documents metrics, what we want. And also, for example, we can see attachment site metrics to see how extensively this grown and to predict what hardware we should to buy. Also, there is some dashboards available on Grafana. The next one is Bitbucket exporter. It's my favorite one. On this provides also some business metric. You can see that how many lines of code or how many commits some people doing on a daily basis. For example, this is example how many open pull requests we have per day. Also, Grafana dashboard, so you can find it on plugins. Bamboo exporter, the last one, it's some newly developed. There is some statistics about active and running agents we can see, and mostly it's helpful to predict how many agents we should add on demand by daily basis. That's all. Thank you.
And we're synced up. Hi, my name is Bob. Appropriate for a lightning talk, I'm going to be talking about time. So first, some definitions. So I think we all know what Prometheus is. Cortex, a multi-tenant and horizontally scalable Prometheus as a service, comes important later. Chronomancer, school of magic involving the manipulation of time in a supernatural way. Chronomancer, that would be this gentleman here, a purveyor of that, and time. So The Order of Time by Carlo Rovelli is an excellent book. Funnily enough, the audiobook in English is actually written by this gentleman, not Dr. Strange. So did you know, based on listening to this book, that time flows faster and slower depending on your elevation on the Earth? And that there is no one universal shared notion of right now. Time, as we know it, is actually a wholly constructed construct of the evolution of the human brain. So I reject your 5-minute proposal here. So why should Prometheus be any different with regards to time? So in Prometheus, the time series begins at the time of the scrape. So if I have a metric, and at time 0, I'm going to scrape that data, and I'm going to create a series that has time 0 at the time of the scrape. Now, I might be updating that metric inside of my application, inside of my target, multiple times, incrementing counters throughout time. But again, when I come by to scrape it again at time 2, I miss the intermediate timestamps, and I get a time at time 2. Or time 1, sorry. So timestamps, because they are persisted in the database inside of Prometheus, are preserved in remote write. So as I send the data to a remote system over remote write, I don't get to change time. Time comes along with the timestamp, with the time series. So for the processing that we do at FreshTracks, we have a data processor that runs as a sidecar to Prometheus that does all of this data processing logic. And that data processor comes in, queries data out of Prometheus, gets back a time series that has been originated at the time of the scrape, does some processing on that data, and generates a new set of series that are a derivative based on the time series that it just queried, but those time series are now different and offset in time from the original ones because Prometheus has to come back and scrape those new series out of this data processing sidecar. So this was an older architecture that we were using. The end goal here is that, so now, advance? Oh yeah, so now we have time prime 0 as opposed to time 0 on this new derivative series. The goal here is that we want to be able to align the derivative series to the time of the original series so that we can draw charts and color these things appropriately as these things are exiting their, the anomaly detection that we're doing. And the interval of time, the scrape interval plus the processing time gives us an offset for these derivative metrics, and this really kind of messes up our graphs. So a couple of really interesting things about Cortex and Prometheus. In Prometheus, the only way to get data into the system is to allow it to scrape. And in Cortex, conversely, the only way to get data into Cortex is to push via remote write. Cortex doesn't scrape, and you can't push data into Prometheus. So we leverage this fact. So now I've got a target. I'm pulling the metrics out. I'm going to scrape with Prometheus and grab time 0 and use remote write to push that data up into Cortex. My processor is going to grab the data via query and get back time 0 data, and then I'm going to process that data and produce a derivative series that is now T prime. But that original series, the derived series, now has the same aligned timestamp as my original series because we control time. And then we use remote write to send that back to Weave Cortex. And everything lines up perfectly. Thank you.
So this is my talk, BMC and Prometheus in 5 minutes. My name is Chris. My nickname is BlueCMD. So let's start. What is a BMC? So BMC stands for Baseboard Management Controller. It allows you to do remote administrative actions such as power cycle a server, or emulate USB devices, flashing firmware, and things like that. It's kind of standard in servers when you buy them today. You probably don't have one in your laptop, but some high-end desktop machines actually start to have them now. Vendors call it different things. HPE, for example, calls it an ILO. Dell, I think it is iDRAC. Supermicro calls it an IPMI, which is a bit confusing. We'll get to that later. Essentially, it's a server inside a server that is always on. Usually, it's spec'd at something like it has an ARM CPU, around 400, maybe 600 megahertz, 256 megs of RAM or something around that. So what's inside the BMC, right? I don't think you're buying this. It's So of course it's modern software, right? So let's look at more what that entails. So I have access to a server that was designed 2015. So this is what we're looking at. So we have a 2.6 kernel, and we have a BusyBox that was released in 2008. So, and this is, again, a server that was designed 2015. Anyway, so this is the software that is running on this CPU that has access to flash your BIOS, right? So if that is good, I'll let you decide. So no rainbows in this one. So, and we also have GPL code, supposedly. The kernel modules do claim licensed GPL, and those who have done some kernel development knows that that unlocks some kind of nifty functions you can call. So maybe, I mean, I did request this source code, and I'm sure they're gonna get back to me any day now, but we will see about that. So what does this have to do with Prometheus, right? So we have a server that is always on, and it has all this, like this is just maybe 1/10 of the metrics that I can get from this thing. So this is juicy metrics that we obviously want to plot and graph and maybe alert on. So we can use this tool called IPMI tool, and out it goes. So what is this IPMI stuff? So it's defined in this document called Intelligent Platform Management Interface Specification 2nd Generation version 2. It's 644 pages, and I'm sure it's very fascinating. I didn't read it, so I don't know. But what it does not specify are these read-write commands that are model-specific, that only your vendor or OEM knows what they do. For example, you have this 32AA00 on my server that makes a mysterious CD-ROM drive appear. It does not have any kind of media attached to it, but supposedly you can use it to flash your BIOS somewhere or somehow. Bonus, it does RPC calls over something called a keyboard controller style. It doesn't, like, I thought it was the subsystem, but it's actually style. I don't know, but it is some kind of interface. So yeah, let's try to, like, this all sounds scary, right? So let's use the node exporter. So what's the problem here? You just SSH it, run sudo, and install it, right? Well, the problem is you don't have root access. And since this is a 5-minute talk, let's ignore that and do something like this. And just gain root. Okay, done. So let's just download the node exporter, apply some patches that are conveniently available, build it since it's an ARB CPU, and Go is kind of awesome when it comes to being portable. Copy it to BMC, which is, you know, that step is not easy as well, because obviously you don't have a SCP and things like that. Run it, and bam, you now have power status that you can now graph. This is one of the metrics you can get, right? So this is just an example. So, and this is always on. So this is actually, I think, the only way you can get an authoritative that your server is off, right? So this is, you can ping it and alert on ping not replying, but this is actually, it's off. So yeah. I'm gonna do an ad for a product I'm working on. It's called UBMC is the working name. It's essentially removing all this outdated stuff and replacing it with, you know, new software, open source, debloat, use Prometheus exposition format, gRPC, SSL certificates, all that stuff. It's very early. I don't have a fancy website or anything. Just ping me if you're really interested in this, and I'd love to hear your thoughts. So yeah, that's me. If you want a demo, you can click on that link. I don't know how, but maybe maybe I can post it on Twitter or something, and you can check it out there. Thanks.
Very much. So we all know status pages, and why are they useful is because when you have lots of users and that they cannot reach your platform, you want to let them know that you are done, so they don't call you, they don't phone you and flood your service desk. But how can you make a status page that will actually match what your service is, so that when you are done, well, the people know it, and that you don't need to get like 30 minutes of actual phone calls because before you can actually update the status page. So for that we use Prometheus, because Prometheus, it contains a lot of data, but not only like the technical data, like, okay, my server is up, but also the business data, like, am I actually getting requests now? Do I have users that are using my service that I get like a good answer that I can actually service? So Prometheus has a nice overview of all of that, and it knows if we are up or down. But as an end user, you don't want them to know, like, okay, we know that we are up because in the last minute we have like 1,000 transactions that have succeeded. So we are using the rate method for that. So, but for end user, we say, okay, the rate and the error rate, we call that the availability, and then the response time, we say this is like the duration. So the end users, they get that information. And then we define for the end users, okay, you can know that we are completely down, or that we are degraded, or that we don't know. Like when we say it's 1, it's that we don't know. And 1 is also like the value for the absent in Prometheus, so that's kind of nice. And 0 is when, okay, this is working, it's fine, you can use the platform. So in practice, we define some metrics which we call public dashboard, and we say, okay, this is the availability for the service X. And then X can be like the front end or the database or anything like that. And then we aggregate that into like a big service, into a matrix that represents the status of the complete service. Like, okay, this is my shop, and the status is like, it's green, but it's slow, something like that. So we use some queries, like we take the minimum over time of those 0 to 4 metrics, and then we say, okay, we take that value, and this is what the service looks like now. In Prometheus, then, we have a dedicated Prometheus for end users that only contains those metrics, because so that we can actually have lots of requests on that Prometheus without impacting our production setup, and we also know exactly which metrics are inside that one. And we also use the Prometheus consoles directly, so that it's Prometheus that renders the dashboard directly. So that we don't need to like update the data, upload the data somewhere else. It's just that Prometheus server is just directly doing the dashboard things. And we use the CDN to host the CSS files. We also have an exporter that's actually a web interface that we can use. You can say, okay, I want a message, or I want to say, no, the service is fine. So you can actually create some metrics on that web interface that say, okay, no, the value is -1, so that you can say, okay, this will be more important than what Prometheus is actually thinking that the infrastructure is. And that's, that end-user dashboard is used by non-tech people. So it's just like a web page, a form that is also an exporter behind the scenes. I've put the code on a GIS, so you can find that, and if you want some inspiration about how we did that, you can find that. And at the end, this is just like a screenshot of today, which is not a really good day, but this is what it looks like at the end, and this is completely hosted, done by Prometheus, and it's enough for our needs, and I hope I will convince people not to remove the console feature out of Prometheus. Thank you.
Hello, everyone. I'm Nikunj from Uber, and as some of you requested, I'm going to give a quick talk about M3 and how it can work with Prometheus. So just a very high-level overview. Internally at Uber, we use M3 to power our dashboard, so this is kind of how it looks like. So it's a Grafana dashboard. And we also have our inbuilt alerting service, which we call UMonitor, and which does alerting. So I want to talk about why serving metrics is so complex, considering our scale. So I want to start with some numbers. So we do about 400 to 600 million pre-aggregated metrics every second, which is about 130 gigabits per second we're pushing. We do about, so then we aggregate them, and we are storing about 20 million metrics every second, which is pretty big still, and it's about 50 gigabits. We have very high cardinality, and we do about 6 billion unique metric IDs right now. I mean, this is a graph we took recently. Talking about egress, we get about 2.2 thousand queries, which comes out of our 9,000 Grafana dashboards and about 150,000 real-time alerts. These alerts are business level alerts and some of our system. The dashboards can fetch a lot of data points. I mean, our limits are a little higher than Prometheus, so we do about 30 billion data points every second for fetches. And this is not, like, it's a moving target, so it has been constantly growing. We had about 20% uptick in the last quarter, 50% uptick in just the unique IDs in the last year. Our QPS has increased 100% in 1 year. Ingress has increased 90,000% in the last 3 years. So just a very quick overview of M3DB. It's an open source distributed time series database. It works really well for metrics. I mean, right, we only support float 64s. So I wouldn't call it very generic right now, but still for metrics use cases is really good. We can support arbitrary timestamp precision. We support variable resolution and retention. We don't need any compaction. I mean, because we are doing downsampling before storing. We are replicated, we have zone-aware layouts, and the replication factor is configurable. Within Uber, we run RF3. We are strongly consistent, and we rely heavily on etcd. So we rely on etcd for application, for consistency, and that's how we can keep M3DB itself kind of simple. And we support fast node add, remove, replacement. So this is a very high-level diagram of how M3DB looks like. We have a database. So whenever a write comes in, we write to a commit log. In case the host crashes, we don't want to lose it. Then we have a bunch of namespaces. So we use namespace for variable retention and resolution. I think somebody asked that question earlier. And we have an index at the namespace level. Then we further split each namespace into multiple shards. Sharding is a technique we developed later on so that we can assign a group of series to shards, and we can only lock at the shard level. So at that QPS, at that write throughput, we noticed that if you do a global lock per namespace, it's very slow. So we kind of divide it into shards and do locking at that level. So series is made up of blocks. So a block is very similar to Prometheus 2.0 block, I would say. And we have a bunch of encoders for blocks. So we need encoders because you can get data out of order. So we kind of support that. I mean, we couldn't neglect it because some internal clients were sending us data out of order. So we actually use multiple encoders if we get data out of order, and it works fine. So coming to our open source strategy, this is what we did in H1 of 2018. So we have a bunch of hosts, bunch of clients, and you have a Prometheus instance, which is scraping metrics. So what you do is you deploy a empty query sidecar next to it, and the empty query sidecar uses the Prometheus remote read-write API and writes it to M3DB. Now M3DB internally has its own index. It has an etcd cluster, embedded etcd running, so then it can serve both your write and read request using the long-term remote storage interface. I also wanted to briefly talk about this new M3 query engine we're building. So internally, we noticed that our query engine has hit a lot of bottlenecks. So the problem is our internal users are actually not happy that we have any limits at all. So they would want no limits on our query. Cool. So the reason we need limits is because we calculated some queries can actually get up to 10 gigs of data points, even at our current limits. And if you send 4 such queries on one box, you can easily kill that box. So the way we are planning to solve it is through redesigning our data model. And that's what the new query engine is all about. And an interesting thing is we're developing it completely in open source. So you guys can go check it out. Some things we're doing there is removing time series limit. We do that by improving memory efficiencies, enabling streaming back to client. So if Grafana in future supports it, we can even stream it back to Grafana. And we're trying to keep data compressed as much as possible and only apply functions when we really have to. So if you had, let's say, a scale and then a sum, we'll keep data compressed at the scale level, but when you do the sum, we will decompress one column at a time and apply the sum, and that kind of reduces the memory footprint a lot. All right, yeah, that's my talk. And if you have more questions, we can talk about later.
Thank you very much. So,
Hello there. So yes, like Brian said, I'm insisting on giving the same talk every year, just giving a startup update. First, my presentation. I've been in Debian for 13 years. I used to work at Google, and that's where I learned about BorgMon and loved it, and that's how I jumped into Prometheus as soon as it came out, and I started working in packaging. I don't work at Google anymore, so I'm still happy as a freelancer. I recommend everybody to try it. It's great to be out of an office. So why Debian? like I said other times, we are not hip, we are old-fashioned. We don't run scripts from curl. We don't download binaries from the web. But it has many good things. It runs on everything. It runs on phones and space stations, all kinds of weird architectures. We are the source, the upstream for 130 distributions, including Ubuntu and many others. We offer trusted binaries that are mostly reproducible. The reproducible builds effort is getting traction across the free software world and was started basically by Debian people. We give you package management, so you install an application and then you don't need to remember when it's installed and how to remove it and all that. Integration with other services, automatic starting at boot, configuration in the right place, all these kind of things that you have to do by hand or put it in /opt or /home or something like that. And security support, which is also very important and something that's usually forgotten in the hip communities that just don't load from head. And you still get up-to-date package versions, at least in the case of Prometheus, because I'm doing a lot of work on backporting all this to stable. So even if Debian only releases every 2 years, more or less, you have the latest Prometheus version right now in the backports for stable. It's very simple to install Prometheus. Like you just run this command and you have Prometheus installed, and it automatically installs the node exporter too, but unless you tell it not to. And it will be configured to self-monitor and monitor the node exporter, so you have an instance running in 2 minutes. Most of the packages that we prepared are available in 10 or more architectures, with some exceptions because of Go support. We try to keep the backports really up to date. And I started even only myself, but slowly but surely some other people are getting interested. Because also the interest of people on using Prometheus in Debian is growing. This is the current status. You see, first column is what you get from installing stable. Second column is what you get if you install the backports, and the third column is like the bleeding edge. As you can see, for the core packages, like it's all pretty much up to date. Managed a few months ago to get the Alertmanager into a new release. I was blocked for a long time because of the new front end. So I did the reasonable thing and removed the front end. So Alertmanager in Debian doesn't have a front end. But it's totally functional and you can use the CLI. Well, you have to make trade-offs. No, actually, there's some ideas to have a front end there anyway, but we're working on that. But then you have the libraries for different languages, Golang, Perl, Python, Ruby, and for Django. That's updated today, actually. Then a lot of exporters, as you can see, all kinds of things, more growing. The ones that have asterisks are because they were uploaded in the last couple of weeks and still haven't reached the archive. And well, there's something new. I didn't say this last year, but help is welcome. This is a lot of work. I hear from people in PromCon and in other places thanking me for the work on this. I tell you, we need help. If you work for a company that's using this, maybe make them give you a couple of hours to work on Debian. That would be great. We need to keep all these packages up to date, bug-free, package all the dependencies that every time there's a new feature, I need to package 100 more packages, libraries. I would like to work more on integration. Actually, I was looking to the JSON.NET talk, and I think that would be an interesting thing to try. And all this work gets worse with all these complications from the Go ecosystem, all the vendoring and the APIs breaking all the time. So that's one of the reasons why sometimes we don't keep up to date. And yeah, JavaScript, that's why the Alertmanager was so lagging behind. So yeah, that's all. I'm still a freelancer, so anybody wants to hire me, that's also offered. Thank you.
All right, a fair warning up front. This is going to be a non-technical soft talk, so if you want to check out Hacker News, Reddit, or whatever, now is the time. I'm still Michael Hausenblas, still work at Red Hat, still work at Kubernetes Upstream. And you know what I love most about open source, besides the fact that, you know, you can look at the source and fix the shit there. But the thing that I love really and care most about open source is actually the community. And I'm gonna try it with a little analogy, maybe that works. So we have 3 kids, aged 11, 13, 15. Hi, in case you're watching, Daddy is on TV. And you know, when they are born, when they are young, you can't really leave them alone. You cannot leave them unattended for even 30 seconds, right? You really have to look after them, care about them very, very closely and deeply. As they grow older, at some point in time, you know, they somehow develop their own traits and characteristics. The one focuses more in sports, the other one more in computers or whatever. And it comes to time where when you say, hey, how about we're doing something together today? They say like, you know, Daddy, I love you, but I really want to hang out with my friends. Nothing personal there, right? And that brings me to the conclusion, to the end of my lightning talk, and that is, in order for them to grow, you have to learn to let go.
It is about deployment. For some reason, it is stress or relaxed. So we find out that to use Prometheus to be relaxed. And the best scenario, what we do, the mobile messaging company, and I develop this products, which is that red rectangle. It is some kind of services which contact with operators, mobile operators. And for us, we don't have the strong knowledge if they're still online, because it's many, more than 1,000. And when we deploy, we actually don't know if something broken, it's our problem, or it is the operator down. And we started to use it Canary. We find this works. So what does it mean? Then we deploy every microservice node one by one, and to just reduce traffic. But the problem, how we prove that it's still of this small amount of traffic, it still works. And we decided to try with Prometheus. From Prometheus, we extract some kind of data. For example, in Java, for logback, it is easy to log that every errors what we have. And we decide what we will compare. We can compare the same instance with that previous version, or we can compare with another online instance, and to take interval what we want. And to see, on this, we have pretty good difference. That means we can proceed deploy all other instances of the application service. So something like that looks. If we deploy the one node, the graphic double it, that we have problem, we don't need to deploy everyone. And to build some pipeline, we check this in one job. If we compare one instance, check it with Prometheus historical data, it told that threshold satisfied, we can deploy all another 80 instances and it works on production. So that's all. Thank you.